Greetings, everybody, and welcome to my video. Tonight, we're going to draw a two-dimensional development of a world, and then we're going to make a three-dimensional model out of that two-dimensional development. And we're going to use a map similar to the map that's pictured on the UN flag. Okay, so our world is going to have a diameter or a circumference of 24,000 miles. And we're going to draw it to a scale of 1 inch equals 1,000 miles. Okay, so I'm going to use calculations from this Machinery's Handbook here. It's 11th edition, and it was printed in 1941. I don't know if you can see that there. But so this is before the advent of NASA, so I'm hoping these calculations, although they are the same, will be better. To find the diameter of our planet, we have to take the circumference and divide it by pi. So here's my calculator here. I don't know if you can see that or not, but we'll take 24 divided by pi equals. So the diameter of our planet is 7.639 inches. Okay, so we're going to be using a compass to draw this. So I'm going to divide that by 2 so that it'll give us the radius. And we have a radius of 3.8197. And just for accuracy, I have this inner caliper here, and it is set to 3.8195. So it's off by 2/10,000ths of an inch, but I think we can live with that. Okay, so I will take the compass here and line it up with that to make sure that we got the right. It's right on there. That's pretty good there. Okay, so put that to the side there. Move this out of the way, and we're going to draw our planet. Try to put a nice dark line there so you can see it. My paper is a little bit warped, so it's kind of hard to draw. It just comes out okay. Okay, so that is the diameter of our planet. I'm going to extend this line up right here a little bit, just so that it has a little better continuity here. All right, now we know that our circumference is 24 inches, so we have 4 quadrants here. So if we take 24 divided by 4, we get 6. Okay, so what I'm going to do is I'm going to take my dividers, okay, and I am going to divide this quadrant right here by 6. 1, 2, 3, 4, 5, 6. Okay. So I'm going to take these little this here. That looks pretty close. Close enough. And I am going to just take And starting right down here at the bottom of our world. And I'm just going to put a little check mark right there, just so I know where my center line is. And I am going to work my way around here, just like that, so that you can see the center line there. And let's check and see how accurate we are here. How close are we? We're off a little bit. That's okay. Now, you know, if you're going to make an actual map that you're going to be ocean faring, of course you would want to make it bigger, and you would have hundreds of maps by the time you made every map for every quadrant as you go around, and I'll explain that in a minute here, hopefully. Okay, so now what I'm going to do is I'm going to take those little tick marks there, and I am going to just project a line over to my center line here, just to put a little one there. It's just a little crosshair there. So we have it there because we're going to need it. One of them across there, just like that. Okay. Then we're going to take our compass. We're going to place it on our center, and then we're going to adjust it so that it strikes that line right in the center there. And then we're going to draw a circle right there. Try to get it dark. Okay, and then we're going to go down to the next one. And we're going to do the same thing again. And so on until we get all of our lines drawn here for our projection, because that's what we're doing. We're making a projection drawing, so we want it to be as accurate as possible, so that when we actually cut it out and make our three-dimensional model of our planet or world, however we want to call it, we'll call it everybody's world. Just keep working our way around here. Try to get it dark so you can see it well. My HUD is going to be even sharpened here shortly. My compass here, because it's getting pretty dull, but it makes a sharper, thicker line so you can see it. Okay. So remember, the more accurate that you do this, the more accurate your world will be. Okay. So that's that. Okay. So now we have to put our elevation lines in, just like they have on the UN map. Okay. So I'm going to divide mine into 24 sections. Okay. So if we take 360 degrees, that's a full circle, 360, and we divide by 24, you get 15 degrees. Okay. But for what I'm doing here, I wanted to straddle this center line right here. Okay, so I want to divide that by 2. And that gives us 7.5 degrees. And I have this adjustable triangle here. And it is set at 7.5 degrees. So I am going to go ahead and strike a line here from center. All the way out to the edge. Okay, and then I'm going to flip it over this way so I can do the other side. Okay, so that'll work for that one. I'm going to go ahead and complete the going around the lines there. Okay, I've taken the time here to draw the rest of the lines in there. Okay, so now you can see how that resembles the UN map. Okay, now remember these lines right here are center lines. Okay, that was just for lining it up. Okay, but resembles the UN map. So on our world, we're going to have, let's see, we're going to have a land mass that goes from here, from this point right here, okay, to here, to here, to here, to there, to there, to there, to there, and back to there. Okay, so we'll have to cross over this line. That's going to be tricky to figure out, but we can do it. See, I'll show you how. Okay, but that is the landmass on our world. Okay, so now now we're going to do a flat projection of this world right here. So what we're going to do is we are going to take this long square right here, I guess, and we are going to project down to here. Well, let's see here. I want to get first off, let's extend our line down. So I might have to go this way with the way this is set up here, so everything stays square. Okay, run this line down. Went over the triangle there. Line off. Okay. So then we're going to go down this line 6 inches, because each quadrant is 6 inches. So we're going to do 1, 2, 3, 4, 5, 6 inches. So we're going to go from here to there. Okay. So what I do my alright, so I don't have to draw the lines too long, so we'll just go mark out every inch for 6 inches. Okay. Now we're going to come in here Okay, so now we have these lines laid out here. Okay, so what we're going to do now is project down all these points where they intersect along this line and along this line. So we're on either side of our center line. Okay, so I'll just start right here, just projecting down. Okay, so that one is that one. That one is that one. That one is that one. That one goes to there. That one goes there. And then we have the center. 1, 2, 3, 4, 5, 6, 7. Or did I miss one? Oh, yeah, I did right here. Okay, so I missed one. So let's come back in here and erase these out of here. Bummer. It happens. Okay, let's try this again. Okay, so that one's there. So the next one is that one. Is there. So we have to go to this one. And that one goes to there. And then we go to this. And then this one. And then this one. And then the center is at the top. So I'm going to fix these lines here. Okay. So that's kind of got it erased out of there, but those lines project down from these points up here. So we'll come over to the other side and do the same thing again. Hopefully this time I don't screw it all up again. Gonna get my hand to put everything to cooperate with me here. That one goes to there. That one goes to there. That one goes to there. Okay. So now what we're going to do is we're going to construct an arc in here that goes from this point, a smooth transition through each point to there and to there. And how we're going to do that is we're going to use this. This is called a flexible curve. I have lots of French curves, falling everywhere. Lots of French curves and stuff, but I don't think I have one that's will fit that. It's too much of a bend in there. I need a real big one, and I don't have a real big one. That one goes up there. So we will use the flexible curve. Okay, so sometimes it's a pain in the butt to get straight. It's little bends in it all by itself. Okay, so we're going to just place this down here. And try to eyeball in there a nice straight line, or a nice curved line, I should say, because it is a curved line. Well, it doesn't look too bad. Let's see how that goes. Well, that didn't come out too bad. So I'm going to go ahead and do the other side. I'll just flip it over here. Probably have to change the whole arc here because it's on the side. But that's okay. We'll get it in there. Hopefully. Not too bad. Well, it's not too bad there. It's a little bit muffed right there, but you get the basic idea. So now, you would have to do that 24 times across this piece of paper here, rolling it to every quadrant as we go around. Okay, so you would want to roll it about this point right here till these are flat, and then you could draw the next one. Okay, or you could take and make something like that and just copy the same thing over and over and over and over and over. Okay, which is what I plan on doing with mine. Okay, but first I'm going to show you how to get. Let's see, we need this point, this point, this point, and that point right there, and that point right there. Okay, so we know where that point is. Because that point right there is right on our center line and right on the intersection right here. So that point is right there. Okay, and this point right here is at the next point down here, so we have to, so our landmass would go that way. Okay, and this landmass right here, we would have to calculate. We would have to strike this line out to here, see where it meets out here, because it should be out here somewhere. Okay, and then we would know, our radius right here. Okay, and we would have to calculate this distance right here through division of our, and then we could get a close approximation of where this point is on this line right in here somewhere. Okay, so we'd have to say that somewhere in here, without me doing all the calculations and everything, that point would be somewhere right there. So our line would be right there. Okay, now this line from here to here would be drawn in the next quadrant right here. So this point right here, as this comes up at an angle, here, I'll lay this in here, and I'll draw the next one in there using my template. Now, it's not a very good template, but it's going to do what I want to show. Okay, so I'm just going to take and put that one in there like that. Okay, so here's our next one. Okay, so now, knowing what this point is straight across from this point. And then it goes down to here, which is this quadrant right here. So the line would go like this. Okay, then we would draw our next one in. I hope that's pretty square there. And we draw that in there. Okay, so now this point right here is right here on this one. Okay, so now we have to go from here to here, and that would be down here. We have to extend that line out. Out of the way. Out of the way. So we'll extend our line out here. Okay, there. And actually I needed to extend out the other one. One more. Okay, so extend that one out. So this point would be from here to here on our landmass. And then it would go from this point to this point right here. And that's that point right there. So then we would come over to this one and go from here to here. And then it goes back down in this one, so we would come over to this one, and it would go from here to here. Okay, so then we would come over on this side and do the same thing. Construct another one here. Make sure I get it nice and square there. Try to anyway. My best. Okay, so we're going to say you can draw that in there like that. Okay. So now our landmass is here. We're at this point right here. Okay, so over here, this is where it is. And it goes up to this point right here, and we know what that point is right there. That's that point right there. And again, we go to this point here. So we go from here to here. And then that's where this meets right here. Okay, so now you would have to draw, since we have 24 divisions, you would have to draw 24 of them across this sheet of paper here. And then you'd have to draw 24 of them upside down, because this only represents the northern hemisphere of our world, and the southern hemisphere would be down in here. So you would have to flip it over. So that I leave myself enough paper. Okay, we'll take a break.
Okay, record.
Okay, so you would have to, sorry about that, I was having a problem with the camera. Okay, so now you would have to draw the southern hemisphere. Okay, but the way this is drawn, you can't just draw it like this, because when you cut it out, it would come out off into pieces. So the southern hemisphere, I'm going to draw it since we don't have to worry about a landmass or anything, because we don't have a landmass in the Southern Hemisphere on our world, though we could very easily. Would just be more calculations, and I'd have to draw the landmass on the Southern Hemisphere, however shaped that was. Okay, so there is the Southern Hemisphere. So what I'm doing is offsetting it so that when you cut it out across here, because you're going to cut this out right here, so that all you have is just these bunch of spikes sticking up. It almost looks like a crown with another crown on the bottom of it the same way. You would cut it out in between so you have all those spikes sticking up. And then when you bend it around and bring all these points together here, you're going to have a ball. And then when you do the same thing down here, you'll have a ball. And then we'll have a ball with our ball Earth. Okay, we're going to pause it for a second and I'm going to do some work here. Okay, well, if you've been following along here, this is what your drawing should look like. I hope it comes under there. That's what it should look like. Okay. It's kind of glaring out a little bit there. Alright, so we have the Northern Hemisphere. And we have the Southern Hemisphere. Just like that. Okay? So, and then we have our landmass drawn in there. I was thinking about taking our landmass here. And we can just shade that in there. Just like that. Because that is our landmass.